All right, ladies and gentlemen, let's take a gander at this. On this lovely day, what we're going to do is we're going to find what's called the nth root. So historically, we found things like the square root, we found the cube root, and now we're just going to find what does it mean to find the blank root, the nth root. So by way of simplification first, notice, of course, the square root of 36 is 6. Next up here, that we are going to send this 2 into both bases, and this 3 into both bases. So that's mentally what happens. You don't have to write that out, just showing you. So if I were to go to the next step, I would get 9a squared times 8a cubed. Now we're not quite done yet. Good, so we multiply our two coefficients, and we do multiply these, but practically that means we combine them by adding the exponents. All right, and this last one here, we can just start attacking it one step at a time. So notice my coefficients, the 4 drops down to a 1, the 16 drops down to a 4, just by dividing both by 4. Next, I deal with my a's. So all these a's go away, and one of those a's go away. All these b's get transferred down there to a 7. And all these c's get transferred up here to an 8. So if you have decent handwriting, or you can write very small and legibly, then the method I just showed you works fine and dandy. Now, of course, we just have to pay attention. I have a 1 left upstairs, but I don't need to write that because I have an a and a c to the 8th. So a c to the 8th power all over. Down here, I have a 4, 16's gone, the a is gone, a b, 7. So 4b to the 7th power. And there we go. That as we address this first one here, all we did was take a square root. That's just a conceptual thing. But here, effectively what we're doing is looking at the exponent, and we're dividing by the square root. We're dividing by the 2. The exponent, 2 divided by 2 is 1. 4 divided by 2 is 2. So when we're dealing with just the numbers, that's just straight arithmetic. But this one here is we take a look at the exponents effectively and divide those. So we'll look at that in detail today. All right, so by way of vocabulary, the first thing I want to show you is how we identify certain types of vocabulary. So this first thing here is, of course, we get 16 here. This one here is 64. 4 to the 4th power is 256. And 4 to the 5th power is 1024. So as a result of this mathematical sentence, we can talk about not just 4 squared is 16, but how does 4 relate to 16? Not the 4 squared, but how does the 4 relate to the 16? Using these exponents as what we call roots. So we can say here, 4 is the square root of 16. So this 4 right here, this 16 here, and the idea of the square is because of that. So that's the number root of it has. And so we get each one of these here. And I'll double check if this is cubic or cube, or if they're used interchangeably. The next vocabulary here is that we just want to review real quick what these symbols all mean. This first thing inside is called the radicand. Any expression, number, letter, whatever, the whole thing inside is called the radicand. The symbol itself is called the radical, or the radical symbol. And this is new for us. We're going to have little numbers here outside, kind of like exponents, but notice that it is nestled. It's nestled inside the checkbox there. That has a special name. It's called the index. So that is what we're going to be talking about, the nth root. So this is a to the nth root, or we're trying to find the nth root of a. So there's a couple things to consider. Is if we have the expression a to the n equals b, and a and b are both real numbers, and n is a positive integer, so we're not dealing with negative exponents, then a is the nth root of b. So that's what we call it. A is the nth root of b. However, there are some caveats to recall. The first thing is that if n is odd, so if it's a to the 3rd power, For example, a to the third power, a to the seventh power, etc. If you wanted to find out what the nth root was, in this case the cube root, or in this case the seventh root of b, it's denoted in this manner, and there's only one real nth root. One real nth root. If n is odd, a to the third power, a to the seventh power, then there's only one real root. Whenever, by definition, the nth root of 0 is always 0, so 0, not that one, but if we had the nth root like this, the third root of 0, it's just always going to be 0. However, if n is even, we have some situations. So if n is even. So for example, if I had some number b and I am saying, what's the fourth root of b? What's the fourth root, or the fourth root of 12, or the fourth root of whatever? If b is positive, the number inside is positive. This is the same for square roots, which is where the square root idea comes from. There are two real nth roots of b. It's the positive, which we call the principal root, or the principal nth root, and its symbol looks like this. The negative root, we just put a negative in the front. Just by way of example, what is the square root of 100? And because there is a hidden 2 right there, we say square root, but this is the only one that has a radical symbol with no number, because it's implied that that's a 2 there. So what's the square root of 100? Well, the actual answer is 10. That's the principal root. But if I were to solve a problem that looked like this, and I took the square root of both sides, like so, then there are actually two answers. 10 is the principal root, and negative 10 is just the opposite there. So there are actually two numbers that satisfy this. What number can I square to get 100? Oh, that answer is 10, or I can square negative 10 to get 100 as well. So there are always two, one positive, one negative. Generally speaking, though, we usually deal with just the principal root when we're simplifying. When we're solving, we deal with both. Next, if b is negative, then that gets into imaginary territory. So just by way of an example, the square root of negative 4. We already have simplified that to be 2i. But since we're dealing with real roots, we'll just say there are no real roots in this case. By way of practice here, number 1, the square root of 400. The square root of 400 is 20, so that's my principal square root. Now this one here, if I square rooted this one, notice I now have a negative inside, brings me into imaginary territory. So my simple answer is just this, no real root. And I do want to clarify for our purposes today, let's also make sure to, because this is a square root, so that's an even, let's go ahead and deal not just with the principal, but with the opposite as well. So we're effectively finding all the square roots, because that'll help us out, especially when we're solving the situation. And I do also want to make one small change. Cubic root, as I looked it up, looks more like cube root there. Now let's look at the cube roots. Now since we're dealing with cube roots, cube is an odd number, so we know we're going to deal with exactly one real real root here. So 216, if I were to write that out, 216, and I would put a small little 3 nestled above the check mark. Some common mistakes look like this. Some people put the 3 very large, but that means 3 times the square root of whatever number is inside. So just beware of notation there. So the cube root of 216, is 6. So that's my answer, and the reason for that is 6 cubed equals 216. Oh, now we have a cube root of a negative. And that is okay. We are allowed to do cube roots of negatives. Why? Because the index is odd, the 3 up there, the index is odd, we're doing negative times negative times negative. So in this case, -7. Because -7 times -7 times -7 is -343. Now the next thing, what about the fourth roots? Well, let's remember our rule. Fourth is even, so we can't deal with negatives. So in this case, no real root. Sure. Let me attack number 10 first here. So the fourth root looks like this. This is how we write it, of 256. If you want to plug that into your calculator, you may. But that's also something we can do in our heads, 4 times 4 times 4 times 4. So the principal root is 4, and its opposite is the secondary root. Let's backtrack to number 8 here to see. We're finding the cube root of the whole thing, which is the same thing as finding the cube root of each component, and then just dividing at the end if possible. So the cube root of 1,000 is 10. And the cube root of 27 is 3. And 10 over 3 is a fine answer there. Now let's look at 1 or 2 problems from the back side and then give you a little bit of time to practice these things. Let's take, for example, number 25 here. Number 25. Well, number 25 is asking us to find the fifth root of this entire expression. And what's nice is I can break this up into each component. If I can find the fifth root of 243, if I can find the fifth root of x to the fifth, and the fifth root of y to the 15. So the first one to do is simply I can plug that into my calculator, or if I know it in my head, I can do it. So this is going to give me the fifth root of 243 is 3. And now the next part here, all we have to do is take this exponent here and divide by this index. So 5 divided by 5 is 1, so the x component is just x to the 1. Well, the next one here, y to the 15. All we do is take that exponent here, the 15, divide by the index 5, and we end up getting 3, so that's my result, y to the third power. And there we go. So dealing with the letters is far easier because it's simply a matter of division instead of a matter of actually computing the root. Now let's go and check out a word problem. In this word problem, a cube has a volume volume equals s cubed, and s being the length of a side. Find the side length for a cube with a volume that has 8,000 cubic centimeters. So of course, we're going to substitute the 8,000 directly into the v, and so we end up with this, or begin with this. Now how do we clear up both sides? Well, I'm going to take the cube root of both sides. So remember that the cube root annihilates, or is the inverse of the cube. Now we just have to ask ourselves, what is the cube root of 8,000? Well, what's nice here is that I can kind of split this up into 2 pieces here. I can find the cube root of 8 times the cube root of 1,000. The cube root of 8 is 2, the cube root of 1,000 is 10, and in the end we end up with 20. So the side length is 20 centimeters. Now of course we can test that just by plugging in 20 cubed into our calculators, and it gets us back to 88,000 cubic centimeters. All right, now what you're going to do is continue working on this sheet and just work through each problem, including number 34.